Okay.
All right, so let's calm down. Okay, now what we're going to do, listen up, there. What we're going to do is we're going to work on fractions. Okay, we've been doing it for what, about a week now, okay? So we're going to go through a certain amount of things because I want you to understand how we use fractions and why, okay? Now, I put a question up here, and the question is, what is a fraction? Charles, what's a fraction? Can you tell me? And here's 1/4. Can you tell me what?
Fraction is it's a fraction. It's have a one in it. Oh, I know what a fraction is.
Okay.
A fraction is two numbers that is.
Two numbers that are what?
Two numbers that are.
Okay, Ladarius, what do you think a fraction is?
It's a multiple.
A multiple?
Yeah, no.
Okay, let's just look at it. Okay, now we have two numbers here. Okay, now what's this number called?
Numerator.
Okay, it's the numerator.
Got it.
Okay. Numerator. Okay, and what is this one called?
Dominator.
It's the denominator. Very good, Ladarius. It's the denominator. Okay. Now, when we look at a fraction and when we work with fractions, what does this bottom number? What does this bottom number mean? Do you know? Okay. Now, let's say, for instance, we take a pizza pie here. Okay, and we're going to divide it into eighths. All right. There. Each of these is 1/8 all the way around. Okay? Your bottom number in a fraction is the total number of parts. So how many parts do we have here?
7.
No, let's count them again. 1, 2, 3, 4, 5, 6, 7, 8. Because I had mentioned that it was 8. So our fraction on the bottom is going to be 8. All right, and this is what we will work with. Okay? And then if we say Charles ate 2 pieces of our pizza.
You shade in.
Okay, so what would our fraction be, Charles?
2/8.
Let's look Charles in. What would our fraction be, Charles?
2/8.
Okay, 2/8. Now, fractions are things when we're working with it. This together is one whole, right? Okay, but fractions allows us to break things up and still measure and work with them. All right. Now, if you look at this, Charles ate 2/8. Okay, well, if Charles ate 2/8 of it, Ladarius, let's say you eat the rest of it, okay? How much did you eat? You ate all the rest of it. How much did you eat?
6.
Okay, hold on. 6 what? 6/8. Very good. Because 6/8 plus 2/8 equals what?
8/8.
Very good. 8/8. Now, if we've got 8/8, 8 over 8, what does that equal to?
1 whole.
1 whole. Very good, Ladarius. Excellent job. Give me a hand. Give me 5 on that one. All right, good job. So that's 1 whole. So look what we've gone to. We started out with a whole here. We ate 2 of them, okay, and then we ate 2/8. There was 6/8 left over, okay, and then we put it together and we got what? 8 over 8, and that's a 1. Okay, now let me ask you this: if we've got so we're doing some adding. So if we do, what does that equal?
Equals 4/4.
Good.
It's equal to a whole.
Okay, 4 over 4 is another, like our 8 over 8. Anytime we have 4 over 4, or 8 over 8, or one number over another, what is that number equal to?
A whole.
A whole or?
One.
Now let me ask you this. If we've got 2,374 over 2,374, What's that equal to?
A whole.
A whole or?
1.
1. Good, there, it's a whole or 1. Okay, so we need to remember that because this will come up many times in your math, all right? Now, we can add, but let me ask you this. Can we add this? Charles, can we add this one?
Yes.
Can we do that?
Mhm.
Okay, 1/4 plus 1/3.
Is. Oh no.
Yeah, good. You caught it. Good job, Judd.
I know
Okay,
why-
okay, hold on, okay. He got it. Good. We can do it, can we?
Because 4 and 4th and 3rd is different.
You got it. 4, this is 1/4 and 1/3. They're different, okay? And if we look at them, like let's look at this. That's a 4th, right? And this over here, if we cut it into thirds, we've got this. These are different sizes, aren't they? So we can't compare or work with them, okay? Unless we can find a common denominator, but in this case, adding 1/4 and 1/3, we cannot do that. They have to be the same, okay? So let's go back to here, and I wanted to ask you, okay, we've got a fraction. So we know now a fraction is something that is a part of something. In other words, if I took this right here, this were glass, okay? Is this a whole? Is this a whole? A whole thing? A whole?
Yes.
Yeah. But if I were to drop it and broke it into pieces,
No.
it'd no longer be a whole, and we actually could consider it a what?
Now if you glue all the pieces, every one of the pieces together.
That's right. You can do that too. But can we consider this a fraction? Start working with fractions if this breaks up in pieces?
No. Yes.
Yes. Same thing as this. Let's say I have an apple. That's an apple. Okay. Now, let's say I cut it right in half. And we have this side over here. Okay. But what is this side here? That is, how much did I cut off?
1.
One what?
1/2.
How many parts? Good, Ladarius, because we had 2 parts. And what did we learn about our bottom number? A bottom number tells us the number of parts, and the top number is going to tell us the shaded part, or what we ate, or what we cut off,
1.
and that's going to be a 1. Okay, very, very good. Now, good job, Ladarius. So now we're going to come back to this, and I want to ask you,
Oh, a lot of
okay, what do we got there? Antonio.
Mixed number.
Mixed number. Okay, now, we've been talking about wholes, we've been talking about fractions or whatever. Now we've got mixed number. What does that mean, a mixed number?
A mixed number.
A
A mixed number has a whole and a fraction.
whole and a fraction. Good job. Nice job. A whole and a fraction. So I'm going to put this up here, and it is. It's like we mix up chocolate milk. We take chocolate, and we take our milk and make a drink. Well, here we take a whole number
Like colors.
and a fraction, and that is a mixed number.
Like colors, like you put blue and yellow
Okay.
and mix green.
Yeah, of course. Yeah, good. And so what Charles was talking about is taking colors, okay, and mixing them other. And the other thing too about mixing them is, what color do you want them? Like you want it, it's going to be yellow, but you want it, you can change it, but it's going to be a fraction depending on how much you put together. Like, are you going to take the whole can of green and the whole can of blue and put it together? You're going to get one specific color, right? But then if you take a half a can of one and a whole can of the other, it's going to change it just a little bit. So once again, you can see how fractions are really a major part of our lives. Okay, but very good. Now, if we look at this, what is what is this 1 also equal to?
A whole.
Well, it is a whole, but if I wanted to turn it into a fraction, what would I have? What can I turn it into, and everything would be just fine? What can I turn it into? And okay, you 2 and a 2. That's right. In this, there we go. Good job, Ladarius. All right, you get some credit points for that. So now, so this is 2. Is this still a whole?
No.
Is 2 over 2 still a whole?
No.
No, it's not?
Oh, yes.
Yeah, any number over another number is still a whole. So we still have, and we will learn how to do this later. We'll use this because we can manipulate the numbers a little bit, okay? And this helps us, where we take a whole number and we break it down into what the actual fraction denominator is, okay? So now we're going to go to a little problem here. Now that you guys know how we can add, and you can also subtract too, right? Okay. Are the rules in subtraction the same as they are? Can we do 4/3 take away or minus 7/3? Can we do that?
Yes.
No.
No. Because the other number is bigger than the 4 is bigger. The 7 is bigger than the 4.
The 7 is bigger than the 4.
So we switch it around.
Well, we don't. No, you can't really. You can't. It's interesting that you mentioned that because we have the commutative property of addition. Adding, you can do 2 plus 3 or 3 plus 2. You can do that. But in subtracting, you can't do that. Okay, because you end up with one of them. You can't switch them around.
You gotta regroup it.
Huh?
You gotta regroup it.
Well, you've got, there are, well, now it depends what you're working with, okay? But for instance, if you're doing a regular addition problem, you would in fact regroup, okay? And here you could call it regrouping, but let's say this, watch this. Let's say this is a 1. Okay? Now, we've got a 1 here. Can we change this into something else?
No.
Yeah.
What can we change this 1 to?
A 3 over 3.
3 over 3. You got it. So we're going to change this to a 3 over 3. Okay? So that means this is 3 more thirds, right? And since this was together as a mixed number, can we add this 3 to this 4?
Yeah.
Yeah, so we can add it, so then this 3 plus this 4, that becomes a 7 too, and now we got, and what's our answer?
0. 0 third. Just 0. You don't have to put the 3.
No, you don't have to put the 3, because 0 over 3 is nothing, okay? Okay, and like if you were to divide 3 into 0, you're going to get 0. Okay, so we've got a little bit of subtracting, and now I want to add a little bit of a problem with it, where we have, this is a young girl. She's got a garden, okay? And when we do problems, we're going to look at it one section at a time. But Charles, can you read that for me? Just till you get to right here. Okay. Oh no, stop here for me, okay?
Denise has a golden.
Good. Okay, stop it. Excellent. Good job. Good job. Good job. She's got a garden. Okay. Do we know anything about the garden? No. We don't know anything about the garden, but she's got a garden. Okay. So, Antonio, tell us a little bit about the garden.
She plants 3/8 of the garden with peas and 2/8 with cabbage. Okay. Now, so that's the whole. Okay. So that's what we have. So let's look at it. Does it say anything about the size of the size of the garden or the shape of the garden? We don't have anything about. No. So we can make anything we really want. So let's make this right here. Let's do something like this.
which always sometimes makes things easy. And what is that shape, Ladarius? You know what the name of that shape is?
A rectangle.
Rectangle. Very good. Very good, Charles. You too. So we have a rectangle, okay? Now, we need to divide it into parts. We need to make it into a fraction, right?
Oh, that's easy.
I know it's easy, okay? So, what do we divide it in?
4, 3. Yeah. No, 8.
Yeah, y'all popping a lot of numbers, but you got it because I will tell you. You have to check into your problem, and what are we dealing with?
2 8.
Eights. We're dealing with eights. So we got to put, this has to be eights, okay? So an easy way to do it when it's something that's even is we're going to cut it in half, and now we have 2, right? Cut that in half, and now what do we have?
And you go that way.
4. And then we put our others right down through here. Boom.
Yeah, there's an easier way to do that, right?
Yeah. What do we have now? We have 8, right? Now, Ladarius, she plants
Then now you get 8.
3/8 of what? It's up here.
Oh, she plants 3/8 of the
Peas, right? Okay, so I'm actually going to take, let me borrow your thing. I'm going to put the blue, and I'm going to put, so we have 3/8. So we go what? 1, 2, 3. Is that right?
Yes.
Okay. So we go 1, 2, 3, and these are peas. All right? And then what else do we have, Ladarius? We've got 3/8 of the garden's peas, and what else do we have in the garden? 2/8 are what?
Cabbage.
Cabbage. All right, 2/8 are cabbage. Okay, cabbage. Okay, so we got cabbage. All right, now from this, once we do that, we can make up some problems, okay? And I'm going to make some up for you, okay? And let's see what you guys can do, all right? So let's say, so she has a garden. It has 3/8 peas and 2/8 cabbage. What amount of the garden is not being used?
Oh, I know.
What's not being used, Antonio?
3.
Okay, 3. 1, 2, 3. Okay, you put it together just like that. And you did mental math. You didn't even have to write it down, did you? Very good.
Not even me.
Huh?
Not even me.
Oh yeah, you did it too. You're right. Okay, now, let's look at another one. How many more peas did she plant than cabbage?
1. 1/8.
Are they right? How many more peas did she plant than cabbage?
1/8.
I know, I got you, but I asked them, are they right? How many more peas did Denise plant than cabbage?
Yes.
Okay, how much peas did she count? Did she plant? Okay, so that'd be 3 what?
3/8.
All right. And what's the cabbage?
2.
All right, now let little Darius work on this here. 2/8. How many more peas did she have than cabbage? So, good, 1/8. So all you did was you subtracted, and it's 1/8. Okay, huh? All right. Oh yeah. Oh no. Oh yeah. You were right when I said let him do it. I was saying you were wrong. I just wanted him to do it. Okay. But yes, you were right. All right. So there we go. So that's what we have in terms of something of a garden and looking and subtracting. And we're going to move on to another one because it's good to start figuring out. And the other thing I want you to do is also think about when you're doing word problems, what you read and what you think about and organize before you make your choices, okay, to solve the problem, all right? So we're going to take this off now, and we're also through with her, and